Good morning, students. In the last lecture, we discussed here some important points about their braking system, just like the types of the braking system, their functions, and the different types. We are used here some hydraulic, mechanical brakes, hydraulic brake, some disc brake, and also anti-lock braking system. Today we discuss here on this depend upon the different type of the braking system, some numerical problems, and these are the numerical problems we taken from there is some reference of here the IIT NPTEL solution problems NPTEL PDF. So we discuss one by one. So the first problem is here: a vehicle mass is 1200 kg is moving at speed 20 meter per second. It required to stop within 5 seconds. Calculate the braking force. So the given values here, the mass is equal to m, the values here 1200 kg, the initial velocity is here u is 20 meter per second, then final velocity is stopping this vehicle is here v is equal to 0, the time is equal to stop this vehicle in 5 seconds, so t is equal to 5 seconds. Using this equation is here in the form of the velocity equation is v is equal to u is initial velocity plus a into t. So when we added this the given data into this velocity equation is here, the acceleration is equal to minus 4 meter per second square. It is nothing but the retardations of there this inverse of here the acceleration. So the now braking force is here, this force into the acceleration is here, mass is given 1200 multiply with this times in the acceleration is here, the required force is here means 4800 newton to stop the vehicle. So this total given is here is total force is 4800 newton opposite to the motion. Next equation, next problem is here stopping distance calculation. So the car is moving, problem number 2, the car is moving at 25 meter per second, comes at to rest with deceleration of meter per second square. Finding the stopping distance, the given value is here u, the initial velocity is here 25 meter per second, then final velocity is here 0, and then acceleration is the deceleration or the retardations comes in the form of here this minus 5 meter per second square. So when it is used into this car moving, as the equation given here is v square is equal to u square plus 2as. So that's why we have put it into this equation is here 25u square plus 2 into this the deceleration value is minus 5 into this s. So time required here, the stopping distance is taken in the form of here this s distance is 62.5 meter to required to stop this vehicle. Okay, then next the dynamic weight of the transfer during the braking. The problem is here the car has following specification, his mass is here 1500 kg, the wheelbase is 2.5 meter, the weight of the CG is here 0.5, height of the CG is here this 0.5 meter, then deceleration is negative, acceleration value is here 6 meter per second square. Find the dynamic weight transfer from the rear axle to this front axle. The solution is given in front of that. This is the value of the delta weight of the transfer is equal to is multiplication of their 1500, the mass of the weight is here, multiply with 6 acceleration, multiply with the height, and then multiply with this the length, so total length. So calculation is comes from there is 1800 newton the weight required. Then the next values here, these values comes into the multiplication of that, this 1500 multiply with 6 and this multiply with 6 into this 2.5. So the total weight transfer this stopping this vehicle with the help of some The dynamic weight transfer is here 1800 Newton. The combined numerical important is here is nothing but a vehicle of mass is 1000 kg is moving at 30 meter per second. It rests on over 70 mm. The CG is here zero point 0.6 and the wheel is 3 mm. To find decelerations, the breaking point and weight transfer is solution is given into them. The deceleration is here with the help of some the vehicle velocity and acceleration equation is v square is equal to u square plus 2as, and that's why required is 0 is stopping the vehicle. Initial velocity is here 30 square plus 2 into this a into the 75. So when we solving this value, this deceleration is here minus 6 meter per second square. Is the retardations or the negative acceleration is here. The braking force is mass into the acceleration is 6 into the 1000 is 6000 Newton in opposite to the motion. Then weight transfer is here is 1000 into the 6 into the 0.6. Then height is here. Then multiply with this L. Stopping distance is 3 is equal 1200 Newton. Then the additional braking system numericals is taken is here. The final value is here deceleration 6 meter per second. The braking force 6000 Newton. The weight transfer is here is 1200 Newton. So next after that the braking system numerical easy level braking force is here. The vehicle of mass is 1800 kg slow down from 16 meter per second speed to rest in 4 seconds. Find the braking force. To calculate the braking force here with some another same is here some another formulas is here nothing but the equation of the acceleration. This equation we are used here in nothing but this v is equal to u plus at. So when we using this value is here the given value is the u is 16 plus mass acceleration 4 and then t value. This t value is given time is here t 4 seconds. So with the help of the calculation, the acceleration is comes is minus 4 meter per second. So calculate the force is here 800 into the 4 minus 4 is minus 3200 Newton. To calculate the braking force is here into this 3200 Newton. Next is the bike moving from 1000 moving bike is 18 meter per second. To stop this acceleration is here 3 meter per second square. Finding the stopping distance is here is v square is equal to u square plus 2as is 0 plus 18 square plus 2 into 3 s. So calculate the values here. Stopping distance is 54 meter. Then the time and distance is here car moving at 22 meter per second. The deceleration uniformly at is 2 into 2 meter per second. To find the stopping the distance is here u is equal to v plus at. So calculate the time response with the help of some velocity acceleration equation. To calculate is your time with the help of some the 0 is equal to 22 minus 2t. This 2t we calculate their time is equal to 11 seconds. The distance is here v square plus u square plus 2as is equal to the value of u. The value of u is here 22. The square of this 22 is 484 minus 4 into s. The value is here s is equal to 121 meter per second. The time is here is the 11 second plus distance is 121 meter. Then the next equation is here, formula is here. The given is vehicle mass is the calculate. So the equations for the weight transfer is here with the help of some problem number 8 is vehicle has distance different specification. The mass is 1200 kg. Wheelbase is 2.8 meter. Then CG of height is 0.55 meter. Deceleration is 5 meter per second. Then find the weight transfer is a multiplication of this given all these values is comes into the values here is 1178.57 Newton for the weight transfer. Approximately we consider there is 1179 Newton. Then this medium hard, the friction limit is here. We calculate in the form of here, this mass is equal to acceleration into this u, mass into the velocity into gravity. This gravity we calculated in the form of the distance is here. Fraction into this value of that, they calculate the value of this s, and this is stopping distance is here is the 50.98 meter, is approximately we can consider is here the 51 meter. So the axle load distribution is here. A car has mass is 1400 kg, wheelbase 2.6 meter, CG of height is 0.5 meter. Then static front axle load is here 60%, deceleration is 7 meter per second. So with the help of that we calculate the dynamic weight transfer, and the new front axle load. So first we calculate is dynamic weight transfer is multiplication of this is mass into this wheelbase into the deceleration into this static load. So when we calculate here is 1400 multiply with 7 multiply with 0.5 multiply with 2.5. So finally we got here is 1884 Newton is equal to 1885 Newton for the weight transfer. Then static front load is here. This weight of the static front load is mass of their weight is calculated in the form of here. The static load is weight is equal to mass into the gravity is 1400 into this 9.81. Its total value is here 13,734 Newton. The front value is here 0.6 into the 13,734 is 8,284 Newton. The next is here the new front load step 3 is equal to total value is here 8,240.40 and 1,884.6. His total value is here 10,125 Newton. Then very hard to calculate the values here is nothing but the calculate the total values is mass is equal to 1600 kg, the speed is here 28 meter per second, the stopping distance 66. Then find the value of their decelerations, braking force, stopping distance, weight transfer. So when we calculate the first values is here acceleration decelerations is equal to u, v is equal to u plus a t is values here. The calculated with the help of this all the given value. We calculate the acceleration is in the form of the minus values here. Minus deceleration value is minus 4.67 meter per second square, and the braking force is mass into the acceleration is here 7,474. The distance is another equations we can calculate here with the help of another velocity equation is v square is equal to u square plus 2as. So s values here 84 approximately or 83.94 values here. The weight transfer is equal to weight into this all the given data 1600 multiply with 4.67 multiply with here this 0.84 into the 3. This total value is given in the form of all this solving the value. So when we calculate all dear students, when we calculate all the students into the all the equations in the form of same given values here is the acceleration values is 4.67, the force is your 4772 Newton, and distance values here then this 84 meters, and weight transfer is 1619 Newton. So with the help of that we can calculate this all the data into them. पण यामध्ये काय करायचं आहे की जो दिलेला डेटा आहे तो दिलेला डेटा तुम्ही सॉल्व करून दिलेला आहे तो तुम्हाला हा पीडीएफ शेअर केला जाईल तुमच्या एक्झामसाठी. हे युजफुल डेटा आहे. ओके, यामध्ये तुम्हाला जे काही आयएसए ॲक्टिव्हिटी दिलेली आहे ते आयएसए ॲक्टिव्हिटी परत तुम्ही सॉल्व करा. सो येत्याला 10 तारखेपर्यंत तुमची ही आयएसए ॲक्टिव्हिटी झाली पाहिजे. तुमची आयएसए ॲक्टिव्हिटी मॅक्झिमम मुलांनी तो जो ग्रुप अलोकेट केलेला आहे त्या ग्रुप अलोकेट केलेल्या ग्रुपमध्ये तुम्ही ती ॲक्टिव्हिटी सॉल्व करून घ्या. ओके. आणखीन दुसरी गोष्ट सांगायची जी आहे ती तुमची ब्रेकिंग सिस्टीम्स आणि स्टिअरिंग सिस्टीम जो कंट्रोल सिस्टीमवरती येतो तो आपला चॅप्टर नंबर 4 कंप्लीट झाला. याबरोबर दुसरा जो व्हॅल्यू असेल ती दुसरी व्हॅल्यू तुम्ही चॅप्टर नंबर 5साठी जे दिलेले डेटा आहे तो चॅप्टर नंबर 5 आपण नेक्स्ट लेक्चरपासून चालू करूया. येत्या मंडेपासून जो असेल तो आपला सस्पेन्शन सिस्टीमच्या चॅप्टर नंबर 5 चालू करूया. त्यात जे थेरॉटिकल डेटा आहे तो तुम्हाला दिला जाईल आणि हा जो चॅप्टर नंबर 5चा डेटा आहे तो तुम्हाला व्हेरीफाय पॉईंट टू पॉईंट्स सिम्प्लिफाईड केला जाईल. ओके. मिड सेमिस्टर एक्झाम नंतर तुमचा रिझल्ट लागला असेल किंवा लागेल आणि यानंतर 8 सेमिस्टर एक्झामसाठी चॅप्टर नंबर 4, 5, 6 हा इम्पॉर्टंट आहे. and from that we select here chapter number 4, 5, 6 from that total equation. Okay, thank you.